5.6, the law of cosines. So easier problems overall because everything's just one triangle. However, the formula is a little bit more difficult. Shepard must be tired. This works for the side angle side case or side side side. So the law of cosines formulas, I'm going to write them all out for you, and then I'll probably manipulate one of them so that you can see how to solve for an angle. If triangle ABC has sides of length ABC, then A squared is equal to B squared plus C squared minus 2BC cosine A. B squared is equal to A squared plus C squared minus 2AC cosine B. Or C squared is equal to A squared plus B squared minus 2AB cosine C. So really, if you memorize this, you should be able to solve for anything that's in here. Obviously, if I'm solving for one of the side lengths, then I would use this formula. But if we have side, 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 then that means that the only thing I can solve for is an angle. And so you're going to need to solve for the biggest one first, or it will not work correctly. So a manipulation of this, I'm just going to do this bottom one since it's down here. If I wanted to solve for angle C instead, I would subtract the A squared and the B squared, and then I'm going to divide by my negative 2AB. So I'm going to have C squared minus A squared minus B squared over negative 2AB is equal to cosine of C. And then to solve this, we take the inverse. So this is going to go away, and I do the inverse cosine of all of that is equal to angle C. And it works the same way for the other ones as well, obviously, just different letters put in there. When we do the quiz, I'll check formulas for you. You'll have to write, like law of sines, you'll write the whole thing. Law of cosines, so you'll just have to write one of them. But if you write all of them and the manipulations, I'll check all of them for you. And then the area formulas I'm about to give you also, I will check those as well. So area of a triangle. These are the ones that would have been given with the problems that went with law of sines, like in that section in our Algebra 2 book last year. The area of a triangle is 1/2 BC sine A, or 1/2 AC sine B, or 1/2 AB sine C.
Are we going to do Heron's area formula?
Yes, we're about to do that. So then the other ones that go with side, side, side is Heron's area formula. And so A is the square root of S times S minus A times S minus B times S minus C, where S is equal to 1/2 A plus B plus C. S is technically the, how do they call it? The semi-perimeter or like half perimeter of the triangle. And so like if we add up all the sides and we cut it in half, you get half the perimeter. And so that's where that comes from. So again, both of those things under this formula you would need to have to get the full credit, usually extra credit points on that for you on the quiz.
Do we have a test over the full chapter, since we already took like the test over part of it?
No, yesterday I told you we weren't doing that. I said yesterday, we're going to take a quiz on 5 and 5, 6. I said, and then most likely what's going to happen is we're going to quiz on the stuff in chapter 6, and then we're going to take a test on all the trig together. All right, I'm going to give you all the option. We can either go ahead right now and do the law of cosines problems, or we can do the area problems, and whichever thing we don't do today, we'll do tomorrow. Which one do you want to do? Which one's more? Like, which one's harder?
Like more problems.
They're probably about the same number of problems. Do you want easier today or easier tomorrow?
I say area problem.
Easier tomorrow.
So area problem today. Is that the easier part?
Area's way easier.
Oh, okay, then I get.
I'm missing your class tomorrow because I had a dentist appointment that got rescheduled, but I don't have an anticipated absence.
That's fine.
since it got rescheduled.
That's fine. Not that worried about it. All right, then we'll do the law of cosines problems first. Now, yesterday we talked about that the sides of a triangle, when you add them together, have to be, if you add any two sides, it has to be greater than the third side. Correct?
Yeah.
Yeah. So the first thing when you do these problems is you need to look and make sure, first of all, that the sides even make a triangle. So I said, well, these are easier because it's always one triangle. That's assuming that the side lengths actually can make a triangle. Okay? So just be aware of that because there's quite a few problems in here that I see that say no triangle in my answer sheet. So that just tells me that you need to check for that. It could be that, it could be something else that's the problem, but most likely it's that that's the problem. So which one do I want to start with? 6. Angle B is 35 degrees. I'm going to do this so I don't have to rewrite the whole thing. Side A is 43 and side C is 19. I'm just doing this so I don't have to rewrite the whole thing again. All right, so this is a side angle side problem because I don't have an angle that goes with the current, like with one of the sides, so it can't be side angle, and so this is our only option. So it's side angle side, which means that I need law of cosines, and so that's one of the things that you need to be watching for is the problems we did yesterday are either, angle side angle, angle side, or side angle. And then these are side angle side or side. You need to make sure that you know the difference in those two because on the quiz, it's not going to say use law of cosines or use law of sines. You're going to have to determine that based on what you're given. And if you try to use the wrong one, the formula won't work. So at this point, what's the only thing that I can solve for?
Side B.
Side B. So side B is B squared is equal to, I'm just going to rewrite the formula, A squared plus C squared minus 2AC cosine B. And so then at this point, I'm just going to plug stuff in. I usually will go ahead and write the square root of the whole thing because you have your calculator, you're going to plug it in. Again, make sure you're still in degree mode, which you should be unless you've been going back and reviewing radians for some reason. So we got the square root of 43 squared plus 19 squared minus 2 times 43 times 19 times the cosine of 35. Now, one thing to make sure you pay attention to when you plug this in your calculator, I would strongly encourage that you put a set of parentheses around this because it's minus all of that just to make sure that it gets it and it doesn't just try to like subtract the 2 and then multiply, because despite how smart we think our calculators are, it's still not smart enough in a lot of cases.
I got 29.5.
So then we'll round it to 30. Again, if they start you with decimals, then you can go to that, but if not, just round to the nearest whole number. So it is 30. And then now what I'm going to do is I'm going to solve for one of the angles. And I said it backwards earlier. We should pick the smallest one first to solve for. Smallest angle. So in theory, smallest angle goes with smallest side. So we're going to choose C is equal to, or we're going to choose to find angle C first because side C is smaller than side A. And so we're going to switch to law of sines. You can absolutely continue using law of cosines, and then it really doesn't matter which order you do them in. But law of sines mathematically is much easier, so I would switch. Algebra 2 did not like that, and they were like, we're just going to use law of cosines the whole time. And I was like, okay, make your life difficult, and that's fine. Anyways, so sine of C over 19 is equal to sine 35 over 30. So then C is equal to the inverse sine, I'm just doing everything in one step, of 19 sine 35 over 30.
About 21 degrees.
So 21 degrees. And then we can easily find angle A. 180 minus 35 minus 21. 124. Now, part of the reason that we start with the smallest side, I had to correct again what I said earlier. I said start with the largest side, is if I tried to take the inverse, if I had done law of sines on angle A, knowing that angle A comes out to be 124, what do you know about taking the inverse of a sine? Or inverse sine? What do we know? What values does inverse sine produce?
Positive angle.
But where?
On the right side.
It only produces values on the right side. So it goes from negative pi over 2 or negative 90 to positive 90. So if I can see that angle A is supposed to be 124 degrees, sine can't produce that for me. Inverse sine can't produce that for me. So we want to start with the smaller angle, aka the smaller side, because otherwise it's going to give me an invalid answer. So like look, type in, let's do this. Sine of A, I'm just going to prove to you. I haven't done this one, but it should. This happened a ridiculous amount of times in, what's it called? Algebra 2. I don't know if they weren't listening to me or if they just did it backwards the whole time. So, A would be the inverse sine of 43 sine of 35 over 30. So type that in and tell me what you get. Or what your calculator says the answer is. 55. Okay. So it might work. But then we do 180 minus 35 minus 55. What do we get? An obtuse angle. Which it can't be if this is the smallest side. Okay. So it might tell you that it's undefined. Or it might give you false information. which is basically what happened here. Okay, so I'm just giving you that warning. Just be careful, because if you do it out of order, you're going to get a value that doesn't make sense. Okay, and while last year I told you, well, if this happens, just leave a note, these values don't make sense, don't rework the whole problem. If this is on your AP exam, you're going to have to rework the whole problem, or it's just going to flat out be wrong. Okay, I don't think this straight up is going to be a question. However, if you're using it for something and you realize you've done it backwards, you're going to have to go back and redo the problem. But I'm going to get rid of that so it's not confusing. 10. This one gives me 3 side lengths. We've got A is equal to 1, B is equal to 5, and C is equal to 4. And then I'll be finding my angles. So, as I have previously suggested, if you're given 3 sides, we should check that those sides actually make a triangle first. And so we do that by adding, basically, if you can add the smallest 2 together and it's bigger than the largest side, then you should be good. But I always kind of like to do a quick check, but that's where I start. So is side A plus side C greater than side B?
No, they're equal.
They're equal, which means that this is no triangle. And then you'd be done. So we can't solve a triangle that doesn't exist. Right, Shepard?
Yes.
Shepherd.
He'll just be confused later. He'll try to keep change flip.
Yes, sir.
He's like, out.
I thought your eyes were open.
Put that in the yearbook.
Who is a dreaming about homework?
Is there a side problem that I can do?
About the doggy.
All right, there's not a whole lot of side problems, so I'm just going to do 11. This one will actually work because it's what I should say. There's not a whole lot of side that actually work out to be a triangle, so we're just going to do this one real quick. 11, 3.2, or hold on. A is 3.2, B is 7.6, and C is 6.4. So I'm solving for angle A, angle B, and angle C. Now, I already told you that this one works, but if you quickly look, the 2 smallest sides added together, so A and C, are they greater than B?
Yes.
Yep, so I know I'm good to go. I always like to kind of, like I said, do a quick look at the other ones, but typically if that works, then they're all going to work. So in this case, I need to solve for an angle. As far as doing with cosine, it really doesn't matter because cosine exists where when we take the inverse? The top. So from 0 to 180. So I would almost recommend when we're using law of cosines that we start with the bigger one, because that way it takes care of that, and then it should eliminate our issues for sine. Because if that angle is obtuse, then we don't have to worry about it. And if it's not, then it's still the biggest angle, and all the rest of them should be smaller. So we should be able to proceed with law of sines thereafter. So, solving for angle B, I'm going to just use the manipulated formula unless you feel like I need to show you how to manipulate again. Are we good? Okay. So this would be, I got to have the formulas in front of me. Solving for angle B, we'd have B squared minus A squared minus C squared over negative 2 AC. And I heard Zach say inverse cosine. That goes in front. Or I think that's what you were saying. And then now I can plug in. Now, since this problem started me out with 1 decimal place, I'm going to keep the 1 decimal place through. With angles, it really doesn't matter, but like if I was solving for a side, I would just stick to the 1 decimal place. But If you like do decimal places and you're supposed to round to the nearest whole number or vice versa, I'm not gonna like take off for that. I'm just letting you know that that's what I would do. So plug in inverse cosine of 7.6 squared minus 3.2 squared minus 6.4 squared all over negative 2 times 3.2 times 6.4. So B is 99 degrees. So that's obtuse. There's literally no way that either of the other angles can be anything bigger than that or even bigger than 90. So I could really go ahead and do law of sines with either one, but I would still just stick to the thing of starting with the smaller one to make sure that you just keep that habit. With law of cosines, you can use the bigger one, but with law of sines, you need to, I would say, just stick to starting with the small ones. There's no issues. So solving for angle A then, we're going to have angle A over, or sorry, not angle A, the sine of A over 3.2 is equal to sine of 99 over 7.6. So I have A is the inverse sine of 3.2 times the sine of 99 over 7.6. $25. So then 180 minus 25 minus 99. 56 degrees, and then I'm done. All right, do y'all want to be done, or do you want to go ahead and knock out the area problems real quick and have all day to work tomorrow? The area problems, there's like no more than 3 of them that we're going to do, so knock them out real quick.
Yeah.
All right.
The sensei is here.
I think when we're done, we should turn out all the lights. We should leave. And make him think the rapture happened. And just all like go in the computer lab or something. All right, 18, find the area. We've got angle A is 52 degrees, side B is 14 meters, and side C is 21 meters. I don't remember. Was it in here that y'all asked me about units the other day?
That was cash.
No.
Yesterday.
I don't know. Okay. Well, anyways, these are the only problems that'll have units on them, the area problems, because they give us units. They don't give us units on anything else. Obviously, if you're given units on the exam, you should keep your units. But these area problems are the easiest ones. Area is equal to 1/2 the 2 side lengths, whatever they are. So in our case, BC, and then sine of the angle. So in our case, sine of A. So I've got 1/2 times 14 times 21 times the sine of 52.
115.84.
So we'll just say 115.8.
Meters.
Meters what?
Squared.
Squared for area, and that would be our answer. The last one, or like the next set of area problems, say decide whether a triangle can be formed with the given side lengths. So again, you should check that on all side problems. And then use Heron's area formula to find the area if it does make a triangle. So 22, side A is 5, side B is 9, and side C is 7. So the way we wrote our formula up at the top is, well, we kind of just wrote it backwards. We need to find S first. So S is 1/2 of the sides added together, so 5 plus 9 plus 7. And do not round this number, okay? It's a 0.5 or a 0. Like, it's, so don't round. 10.5. So then now, area is the square root of S, so 10.5, times S minus A, so 10.5 minus 5, times 10.5 minus 9, times 10.5 minus 7. And then just plug that in. I don't know why I just drew another square root. And these ones do not give units, so we don't need units on these. If you want to write units squared, you can, but we don't know what the units are, so I usually just don't worry about it. And the book doesn't worry about it.
$17.4.
17.4.
Can we just do units squared or not?
She just said that.
You can, you just don't need to. I just realized we didn't actually check this one, but looking at the two smallest sides, 5 plus 7 is greater than 9, so we knew that this one made a triangle.
Will we have to figure out how many triangles there are for these area problems or no?
No. Because technically it's just, these ones are just a side angle side. Or, well, yeah, technically side angle side. It's just usually taught with law of sines because it goes with, like, sine. But it technically goes with side angle side, and the other area goes with side, 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 which are all cosine things. But which is probably why our book does it this way. It's just not the way most books do it.
Yeah.
All right, 26. A is equal to 8.2. B is equal to 12.5. And C is equal to 28. So let's do things in the correct order this time instead of backwards. So, do these side lengths make a triangle? They do not, because A plus B is not greater than C. We add those two together, we get, 20.7, and C is 28. And so 20.7 is not greater than 28, so there's no triangle, and then we don't have to find the area for those. So, if a problem like this was on the quiz and it's not a triangle, you need to tell me why it's not a triangle. Like, don't just be like, no triangle, give me the reason. Same thing on the problems from yesterday. If I ask you just to tell me how many triangles there are, whether it's 0, 1, or 2, you need to show me the reason for why. Don't just be like, oh, it's one triangle. Okay? It could be if it's a, like, angle, angle, side, or angle, side, angle. It could just be angle, angle, side, so one triangle, because that can only produce one. Okay? But any of the side, side angles, you need to have, like, the reason from that table. So, again, I would start looking over that probably next Monday, because probably either Monday or Tuesday we'll quiz on this stuff, because Friday we're celebrating Pi Day. So, anyways.
Is that all the...
I guess y'all probably should probably give you some problems, though.
We still have
Um,
time to go into the computer lab and...
5,
She's moving.
9,
Dang it.
wait, hold on. I just realized this was 9 right here. This was not 10. This was 9. I read the wrong problem. So let's change this. Instead of 5 and 9, let's do 5 and 10. 10's just like 9, basically. And then we did 11, 13, And then area, let's do 19, 23, and 25. One thing I also want to point out, we didn't have it happen. Let me go back up here so I can show you. If we had something like number 6, obviously we solved for the third side length. At that point, once you've solved for that third side length, you should still check that it actually makes a triangle. Because I see a problem in the homework, or well, in the problems, it might not be one that I assigned you, but it gave you 2 sides and an angle, and it's still no triangle. And the only thing I can come up with is that the third side added together doesn't give you a side length that works to actually make a triangle. So you might be able to solve it, but it might not really make a triangle. So just be aware of that.
Time to play.
This one is or